In this question, we're told that it is suggested that a Poisson distribution with parameter lambda can model the number of currents in a current bun. Currents are like raisins, so this is like a raisin bun. A random bun is selected in order to test the hypothesis H0 lambda equals 8, as we thought, and H1 lambda is not equal to 8. And we've been tasked with using the 10% level of significance. We're first asked to find the critical region for the test, and from there, we're further told that the probability in each tail, we should make it as close as possible to 5%. So as always, just be on the lookout for any extra information that you're given in the question, as close as possible to 5%. Here's our hypotheses, and I've split the significance level in two, since it's a two-tailed test, 0.05. Okay, what does this look like on a diagram? Poisson distribution has positive skew. We're looking for these values, A and B, where the probability below A and above B, each of them are as close as possible to 5%. Okay, so let's just check values around that boundary. So we'll start with the probability x is less than or equal to 4, and we find that that probability, that is 0.0996. So it's 9–10%. Can we get smaller? Probability that x is less than or equal to 3, well, that's 0.0424. Okay, that's the one that's going to be closest to 5%. So we're looking for this in our critical region. Let's look at the top end. The probability that x is greater than or equal to 13. Putting in 13 and an arbitrarily large number, 8 is our lambda, and we get 6.4%. Okay, can we get closer and smaller? Probability x is greater than or equal to 14. Well, which of the two of these is closest to 5%? And if you're unsure, you can use subtraction to check. So each of these, if you subtract 0.05, you will notice that probability x is greater than or equal to 13 is the one that's closest. With these values, some students find it hard to tell mentally which one is closest, so just go ahead and check the difference in your calculator. Okay, so the critical region is going to come from these. The critical region is a two-part critical region. We want x being less than or equal to 3, or x is greater than or equal to 13. P probability notation in this statement, that will invalidate the mark you would usually get here. Okay, so next we're told that if lambda equals 10, we should find the probability of a type 2 error. The type 2 error, we can always find that by finding the acceptance region using the new parameter. Well, if this is my critical region, that's my rejection region, the inverse is going to be the acceptance region. So I will be accepting in between 4 and 12. We're going to use the new lambda 10. So in our PCD function, 4, 12, and 10 gets us a type 2 error, the probability of a type 2 error to be 0.7812. We're also asked to find the power of the test. The power is the probability of finding the critical region using the new parameter. So this is the probability that x is less than or equal to 3, or x is greater than or equal to 13. Once again, using lambda equals 10. So two separate PCDs added together should be fine, and we get an answer of 0.2188. Looking at the power and the probability of the type 2 error, you may recognize that we could have done 1 minus the probability of a type 2 to find the probability of the power. But I do want you to have the general format of acceptance region or critical region, new parameter or old parameter in your head, just in case we haven't calculated the type 2 when we were off to calculate the power.